So one definition of NP says that a problem is in NP if it has a short accepting certificate. An accepting certificate is information that we can use to quickly show that the answer to the decision problem is yes, if it actually is yes. And here, short means polynomial size and quickly means polynomial time. So to define NP even more formally, we're going to say a problem is in NP if there is a verification algorithm. So this is basically a computer program, we'll call it A, like a subroutine A, such that for any input for the problem that is a yes, there is a certificate C such that C is polynomial, the size of C is polynomial in the size of X, and the verification algorithm will say yes. But for any X that is a no, there is no certificate C that's polynomially sized with respect to X, and the verification algorithm says yes. So for any yes answer to the problem, our verification algorithm will say yes for some small certificate. Otherwise, it will say no for all small certificates. So for the Sudoku example, the verification algorithm is what we described as something that takes the original Sudoku problem with things not filled in and the answer printed in the back of the magazine with the answer filled in, and it checks to see whether this is actually a solution to that. If it is, then it says yes, and if it's not, it says no. Now this is going to fit the NP definition that we've got here because for any Sudoku problem that is solvable, there's some grid that we can solve it and we can show what that grid looks like. But for any problem that's not solvable, there's no way that we can fill in this grid with numbers so that the verification algorithm will say that it's okay. So it really is back to the definition of basically the Sudoku problem. The Sudoku problem says, is there a way of filling it in? And the certificate that we use is, well, we'll show you how it's filled in. It fits both halves of this definition. So this problem is in NP. Now, let's be a little careful here because Sudoku, as it's typically designed, doesn't really have an input size. All the inputs are of the same size. But you can imagine a generalization of Sudoku where you have a bigger grid and maybe more symbols, and the same kind of verification procedure works. The bigger the grid gets, the longer it takes to run, but it's always a polynomial in the size of the input grid. So let's try to put this definition to work and answer the following question. Is P contained within or possibly equal to NP? So one possibility here is, I don't know, and if I knew that, I'd win a Fields Medal, meaning sort of the equivalent of the Math Nobel Prize, because this is a big, important, open question. Another choice is, no, P is not contained within NP, because if the problem is in P, it means it's decidable in polynomial time, then we don't need any kind of certificate, and so it's not in NP. And then finally, the opposite of that is, yes, if it can be decided in polynomial time, no certificate is needed. Right? If you have a problem that's in P, then you don't need any sort of certificate, so it's also in NP.